Cornerstone Engineering is an engineering consulting and construction firm. It was started in July 2003, headquartered in Louisville. We have now grown from Louisville to serve multi-state area. So we're licensed in 12 states now, and then we we have offices in Indiana, Ohio, and 2 offices in Kentucky, and we started an office in Phoenix, Arizona. FRP stands for fiber reinforcement polymer. It's available in the form of carbon and glass, and it's essentially applying these as an external composite to the structural element, be it a beam or a column or or slabs. Conventional strengthening uses very standard material that has been in use for many decades, like steel beams and steel columns or concrete, reinforced concrete. So we, assess the weakness of the structure. You go ahead and add to that concrete member or a steel member, whatever is available. And most of the time it adds weight to the existing structure by itself. And so you need to account for the additional load that caused by the dead weight addition. And then from there on, you need to still increase the load carrying capacity. And whereas the carbon fiber, glass fiber strengthening does not add any significant weight to the structure at all, while giving the same or higher, strength capacity. One of the major advantages, you need to hold the FRP because it's a lightweight, so you can hand apply the FRP, whereas you need a steel beam or column, you need to lift it, you need a crane and equipment and all of that. In a building where you have a limited ceiling height, that becomes a very important factor, where you cut into the ceiling and it becomes impracticable to use conventional strengthening. So in that case, the FRP will take about maximum 1/4 of an inch in the ceiling. So that's very helpful where ceiling restriction becomes a factor, like parking garages, for instance. We have been designing FRP strengthening for over 15 years now. So we have done over 75 projects to this day. And all these projects have been very successful and very beneficial and performing to the client satisfaction to this date. One is the very first project that we did in 2003 when our firm began, was FRP strengthening for an existing garage, Audubon garage for Norton Healthcare. The conventional strengthening was there before we got in there, and then we proposed FRP strengthening, and Norton went ahead and approved us and selected us as the winning team. And we had to take the garage that was 40 pounds per square foot live load to take a Quint 9 fire truck, which is the largest fire truck in Louisville, to come in front of the building and rescue people. So that was the upgrade that we needed to do, yet not take any headroom from it. So that was a successful project. So since then we have done a number of projects for Norton Healthcare. Another example would be for a water company, where we took a 70-year-old historic filter building, and they were doing a process upgrade, filter upgrade for that facility for $30 million. But the building had structural discrepancies. The walls were all multi-white brick walls, and so we recommended glass fiber strengthening for that. Now, and we didn't have to touch the external aesthetics of the building at all. Otherwise, it may not have gotten the approval. So less than $3 million, we were able to strengthen the entire facility. Now, this is already 10 years old and serving water company very well. And if you go in there now, these FRP strengthening, nobody can even see it that we have been there, because it's been covered and painted and nobody knows at this point. One of our recent FRP strengthening projects is for Humana in downtown Louisville headquarters. Next to the headquarters of the building, there were 3 historic buildings. They wanted to take that building and alter it to be a gymnasium facility, gym, and also some office space there. It was determined by the architect in their assessment that one of the walls was very weak, The south wall was very weak. They had to take the entire wall down and rebuild it. So they had to move over 200 plus employees from that site to elsewhere for a year or so. That would cost logistical problems and a lot of money to move these employees, and then their technology in the new facility, and to lease that facility, and all of that costs, a lot of money for Humana, and besides all the logistical problems they had to sort through. So they approached us and asked us to assess if there is any alternate idea that we could bring, and so we recommended the FRP strengthening technology. That we recommended that when you apply FRP, you don't need to really take people off site and keep them away for 1 year, and we can do an in-place strengthening of the south wall. And so we did the FRP strengthening design, and the wall got strengthened using carbon fiber, external carbon fiber, while all the human employees were still working in that building. And so indirectly, Humana saved we saved a lot of headache for Humana, plus the money, they didn't have to spend to move them out of sight and bring them back again. So it's in certain situations, FRP becomes extremely viable, and that's one example. I believe the FRP technology is growing, although it's still not popular among the structural engineers, because most of the structural engineers like to design new buildings and new facilities. I believe as the emphasis turns to how do you deal with the aging facilities, are you going to abandon it, or are you going to make use of it? So more and more people, or the owners and the facility owners and the individual owners and the government, they like to utilize the existing facility, not to just totally abandon it. It's easy to really demolish and build a new one, but there are times where you cannot do that, especially in the water wastewater sector. You're already in a built environment. You can't demolish and rebuild because that building is in use right now. So I believe the FRP strengthening has a bright future, in the years to come. And also there are R&D, research and developments going on a regular basis to improve this design capacity. And then also we have design guidelines now, which we didn't have 15 years ago. So ACA recognizes FRP as a viable strengthening material. And also FRP is a LEED green material, certified material, because it's basically from waste. FRP is produced from the waste carbon glass. So I believe it has a very good future. Every year the usage of FRP in strengthening aging facilities is increasing tremendously. So I believe that even the structural engineers are going to become more and more familiar with it, and so more will start designing using that. So I see a good future.